Access granted. The airlock is cycling now. Vacuum engaged. Moving to stage 3.
Readings are stable. Proceed with the laser scan initiation.
Inspection is complete and the batch is moving to the next stage.
Excellent. Looks good on the tablet.
The holographic analysis confirms wafer integrity. We are clear to proceed with the lithography sequence.
The spinner has reached 3000 RPM. The photoresist layer is uniform and stable.
Check the thermal readings in Sector 4.
Noted. Adjusting the flow rate to compensate.
Safety interlocks confirmed. System ready for exposure. Approved.
Initiate. Exposure levels confirmed, within specifications.
All right, logging the successful exposure now.
This fluctuation in the critical dimension graph needs attention.
I agree. Increasing the chemical amplification now to stabilize the process.
The system is stabilized. Proceed with preparing the TMAH solution bath.
Confirmed. Measuring the required volume now.
Consistent bubble formation across the surface.
The optical thickness data confirms the etch is proceeding as expected. High-pressure water jets halt the development reaction. The operator checks conductivity sensors to ensure
The topography on this wafer looks consistent with the design specifications.
Agreed. Adjusting the focus now, we should have the full scan result.
Alignment confirmed. Initiating etch sequence now.
Acknowledged. Updating the central system. Process looks stable.
We have confirmation on the wafer placement.
Initiating evacuation sequence. Pressure dropping.
The etch rate seems stable at 15 nanometers per minute.
Good. The SEM confirms the trench depth is within specifications.
Visual inspection complete. Feature definition is within spec. Good.
Let me take a look at the edge die.
The split screen comparison shows slight deviation here. What are the current critical dimensions?
Measuring 45 nanometers, consistent with the...
Let's increase the power slightly for better uniformity.
Okay, applying the new recipe now.
System initialized.
Particle counts confirmed within spec. Ready to finalize the batch record.
Logging completion now. The wafer is cleared.
Recipe verified. Initiating sequence.
Wafer loaded. Platen engaging.
Source current is stabilizing.
Mass analyzer confirms ionization efficiency is improving. The blue plasma indicates stable P+.
Focusing magnets locked. Parameters stabilizing now.
Good.
Intensity is holding steady at 50.
Verify the gas flow rate on recipe transition.
Flow rate adjusted. Initiating cycle.
Measurement cycle initiated. Data stream is active.
Good. Resistance readings are stable.
The uniformity across the wafer looks consistent with the previous run.
Power levels are stabilizing at the target voltage.
Good, good. Check the uniformity on screen 3. It's not. We're approaching the endpoint now. The depth uniformity looks good.
Confirmed. The aspect ratio data is stable on.
The removal rate projection looks good.
The topography scan confirms a uniform surface. A silicon dioxide insulating layer is deposited and patterned with trench patterns for wires. Then copper electroplating fills.
Recipe 47B is loaded, initiating the deposition sequence now.
Confirmed. The planarity metrics look good on the tablet. Yield.
The layer deposition is complete. Coverage verified.
Bond pads show proper isolation. We are within specified.
The results are stable now. We're seeing high performance on the primary cores.
That aligns with the simulations.
Good chest estimates.
The 3D visualization shows the hotspots are localized exactly where we expected them.
Failure confirmed on sector B6. Proceed with marking protocol.
The yield data on sector 3 shows a consistent drop in efficiency this quarter.
The tablet confirms the trend. We should adjust the plasma setting. Alignment checks complete. Initiating the dicing sequence now. The feed rate looks good. Maintain current.
The yield rate is holding steady at 98%.
Good. Let's keep a close eye on the pick-and-place accuracy for the next cycle.
After initial inspection and verification of specifications, the substrate undergoes plasma cleaning and automated vision system analysis for
The paste deposit quality is excellent. Uniform coverage.
We verified the stencil alignment.
Are the parameters loaded correctly for the alphanumeric sequence? Yes. Double checked against the manifest. Ready to etch the Apple logos. Good. Initiate.
A pristine logic board with intricate copper traces loads onto a conveyor belt. A stainless steel stencil aligns. Watch as the precision placement head descends, aligning the chip's solder balls with the corresponding pads on the board.
Settings confirmed for the A17 underfill. Initiating sequence. Looks good. Thermal stability is holding.
The automated optical inspection confirms the alignment is precise. We are maintaining class 100
vacuum engaged. Transferring substrate.
Alignment confirmed. Proceeding with lamination.
Alignment is within tolerance. Proceed with bonding.
Acknowledged. The temperature curve is stabilizing within the specified limits. Monitor the pressure gauge closely during the showing off its features: smooth color gradients, 99.9% touch accuracy, sub 1 ms pixel resolution.
Utilizing precise fiber optic lighting, we conduct a detailed inspection of the sensor's microlens. Placing the fourth element now. Specifications checked. Looks good from here. Centering the stack now. Alignment looks good on my monitor.
Confirmed. We are within tolerance. You may proceed with the final secure.
Go ahead and initiate the calibration sequence. Monitor the stabilization efficiency close.
Are the sensor readings stable for alignment?
Yes, within tolerance. Initiating epoxy application. The captured images on these monitors confirm the spectral analysis data. The results from the lighting chamber test are stable and within beginning the low light test sequence now, sir.
Very well. Monitor the sensor array readings closely.
Lens cover secured. Initiating final laser calibration sequence.
In a state-of-the-art ultra-dry room, an East Asian operator in full moisture-proof gear loads dried electrodes.
The electrode stack is carefully inserted into the aluminum polymer pouch with precision, while the supervisor verifies the moisture.
The formation process begins with a slow charge at C20. The cells are held at 45 degrees Celsius while the voltage is carefully.
Look at this anomaly on the console display here.
Yes, I see it. The preliminary data analysis confirms the trend we observed.
First pass complete. The tabs are secure.
Data logs confirm a stable connection, proceeding with the next sequence. Material certification verified. The specs align with the work order. Good. The surface is clean and ready for the CMM.
I've finalized the adjustments to the coolant pressure.
Confirmed. The parameters look correct. Proceed with the run.
Probing sequence confirmed. All features are within the specified tolerance.
Excellent. We can proceed with the next batch.
Utilizing the femtosecond laser station, we precisely machine the antenna windows, ensuring optimal performance in the millimeter wave.
We utilize advanced mechanical polishing and vibratory finishing techniques to achieve the precise surface finish required for these titanium.
Parameters are set for the blue tint. Readings are stable. Looks good to proceed. The preliminary data confirms the alignment is within tolerance. Proceed with the automated sequence. Acknowledged. Initiating the scan. Coding applied. Ready for verification. Let's check the bond activation. Readings confirm successful. Carefully align the board to the markers, then activate the vacuum seal. Aligned and sealed. Proceeding with the diagnostic.
Adhesive application complete. Positioning the battery now.
Looks good. Solid connection.
Verify the OIS module position.
Position checked. Removing the protective cover now.
Confirmed. The alignment is... Cable connection confirmed. Beginning automated resonance frequency test. Panel alignment is complete. Starting adhesion process.
Confirmed. Curing parameters are stable.
Parameters locked. Initiating test sequence now.
Pressure decay looks stable within the...
Tactile response confirmed on power and volume. Symmetry check complete. All within tolerance. The synchronization rates are holding steady across all units.
Confirmed. Yield remains optimal.
Looks like the rollout is proceeding smoothly.
Yes, nearing completion on this batch. I'm heading to the automated routine on Unit 7 just finished. Look at the variance here. Yeah. That falls well within the acceptable parameters.
Initiating the burn-in sequence.
Power draw is increasing rapidly, but thermal regulation remains nominal.
Cycle time optimization is showing a 15% improvement on the Lightning connector test.
That aligns with the projected throughput increase for...
Capacity verification is complete. The battery health report confirms 98% efficiency. Excellent.
The inspection process combines automated vision systems with expert human oversight, ensuring every device meets our rigorous quality. The laser particle counter confirms the effectiveness of the sterilization protocols. We are maintaining an optimal cleanroom and...
The optical alignment is locked, ready for application.
Confirmed. The process automation is running. Ensure the alignment is perfectly centered in the tray.
Confirmed. Adjustment complete.
The power adapters are all accounted for.
Let me just verify the barcodes on the chargers. Everything seems correct.
Seal applied and secure.
Quality check passed. Ready for the line.
The case count is correct, and the Apple logos are clearly visible through the film.
Our automated palletization system guarantees precision and speed, optimizing the workflow seamlessly.
We need to adjust the AQL for this specific shipment based on the historical data shown here.
Understood. I will update the sample size.
Back glass is detached. The component array is now accessible for inspection.
Understood. Initiating macro sequence on the logic board.
We carefully desolder the A17 Pro chip using the heat gun. Now we place the component under
The initial scan shows a hairline fracture near the power SoC.
All right, I'm noting that as a potential cause on the diagram. Let's run the thermal scan.
If we look at the data visualization here, the correlation between the lab results and the projections is
The system shows the batch is approved, initiating the retrieval protocols.
Excellent. Monitor the automated cranes for any discrepancies.
These are the updated customs declarations for the EU pallets. Ensure they're attached before loading.
Understood. I'll get the labels.
All right, all sensors confirmed active on this ULD. Good. Let's move to secure the main pallet now. Right. Ensure the tension is correct.
Here at the regional hub, we verify seals and documentation, scanning pallets efficiently to ensure seamless cross-docking and
Ensure the accessory count matches the manifest exactly before sealing.
Confirmed. Everything matches the
From our distribution centers to your hands, the global rollout of the new iPhone is officially.
There's nothing quite like the feeling of unboxing a brand new device for the first.
Real-time data optimizes every step of the supply chain, ensuring seamless global.
The global satisfaction metrics are holding strong. This puts us in a great position for the upcoming cycle.